Presenting on behalf of our team on our paper on how Supercomputer can review the literature. So for context, in order to add to the scholarly knowledge that we already have, we have to understand what the knowledge is, the topic, as well as the content within it. In order to do that, we have to read the published articles and research and try to make sense of it, but there are just too many articles. This is a graph that kind of goes to show, by 1965, you see an exponential explosion of scholarly journals. And similar here, by 2000, you see basically the number of articles reach 1.5 million. This is just not humanly possible for us to all read and make sense of every single one of those articles. So the solution that we pose here is to get a computer to read the literature. Now, how do you do that? Basically, get an individual reader's knowledge and try to basically apply that to a computer. So in our case, our second author, Heather Haveman, is the human reader here, and she creates an existing knowledge of the literature. And we apply that knowledge to the online database of all the articles and the focal fields that we'll discuss. And then we basically get it to understand the topics and to be able to basically understand the content within each of the articles. So the topic that we're covering here mostly is organizational theory and sociology, primarily in sociology and management and organizational behavior. To a lesser extent, other things like political science, economics, and public policy. It mainly covers three perspectives: demographic, relational, and cultural. And there are the three perspectives on organizations here. As you can see, they are kind of different in the topics that they cover. So first, the demographic perspective. It focuses on distribution of social actors along salient dimensions of social and physical space. So topics like individual age, race, or gender, work group sizes, and demographic composition. There's also the relational perspective, which focuses more on social connections among people, groups, and organizations. So work group interactions, communication, buyer-supplier ties between organizations. These are the type of things that will be covered. And lastly, the cultural perspective, which focuses on widely shared norms, values, expectations, roles, and rituals, which generate understandings of what's possible and reasonable. So individual socialization into organizational life is an example, organizational or occupational cultures, and diffusion of innovations across organizations in an industry or region. Now, these three perspectives all kind of differ from one another and borrow concepts from different authors. We'll cover this more, but this kind of goes to show they're going to be largely differentiated from one another. So the step one that we took here was to create dictionaries. So each perspective has a specialized vocabulary and words kind of coined and identified by theorists to capture the most important concepts. For example, for demographic perspective, imprinting on societal conditions and founding, inertia, relational, resource dependence, cultural, institutional logic. So we basically use expert knowledge to identify the words associated with each perspective, limiting to 30 key terms per perspective. The way we do this is also with JSTOR data, about 400,000 articles published between 1970 to 2015, all subjects and the topics that we kind of discussed previously, so social sciences, selected subjects in business and economics. And then we basically also get the n-gram files, which basically represents the word combinations that we have. So it could be single words or double words, so words that might be actually a word that might be a combination of two words, or 3 grams as well. And we also grab the metadata, which would include things like authors, the titles, and the dates. And then we map these journal titles to the primary subjects. So the full text OCR files as well, which basically contains all the text of the articles. And we filter this down to about 70,000 articles. Then we kind of cover here the central measure, the key performance indicator for us, which is related to engagement. So we try to measure engagement in 2 different ways here. First one is kind of a ratio of relevant concepts divided by total number of words. That is represented by the first formula that you see in LaTeX here. So basically, it goes to show how many words in the total article are actually the relevant concepts for a given perspective. And what percentage does that actually constitute out of the total words in the article. And the second concept is a little more statistical, and it basically is a cosine score. And that's a cosine score formula there, and it basically measures how close the dictionary sentimental values are to the article's overall sentimental values. And then basically kind of covering that, we then create the embeddings, and these embeddings are basically meant to represent a homogeneous semantics of every article as well as the dictionary concepts. We try to cover both kind of a simple modeling as well as complex modeling, and also kind of trying to customize the model as well as just use a pre-existing one. So we see, for example, we use the word2vec, which is a simple word embedding, basically using the corpus, which is all our articles. And there's a complex version, which is the doc2vec, which also takes into account each individual article as a separate input. We also use pre-existing simple embeddings, which would be glove, very commonly used. And also a complex version of this was a recurrent neural network with glove as an input vector, where we basically use the pre-existing word embedding of glove as inputs for all the articles to generate basically a homogeneous embedding per article. And then lastly, using those embeddings that we created, we basically do model validation of those four things that we covered, as well as the ratio engagement metric that we covered. So for each article, we know the associated engagement scores and the foundational text citation counts, so how often it's cited. So we basically try to compare and see which vectorization method has the strongest relationship with foundational text citations for each perspective. In our case, the X input here is the word count, or the cosine scores for each of the perspectives, and the Y value is basically the number of citations for each of the perspective. We basically try to validate the models in two different ways. One, correlation, so simple comparison between the X and Y, and try to see if there are certain modeling methods or certain engagement methods that basically get higher correlation values. And second, we do a more statistical kind of modeling where we build a predictor using logistic regression to basically based on our X and Y variables. This is the result that we saw for correlation based on Pearson's correlation. We basically see here that the raw word count as well as word2vec kind of see the best results. We actually see that doc2vec as well as infracent, which are kind of like the more complex models here, don't really show strong results. And this is likely because of kind of the distorted noise that's created by how complex the model is. We also use the logistic regression predictor for a more kind of statistical analysis to it. And we see here basically R-squared value to see how good the model is performing and how good the model is at actually predicting the number of citations. And we see here basically that word2vec performs by far the best. And we see again the infracent and doc2vec, which are the more complex models, don't really seem to perform that well for any of the three perspectives. What are the kind of key takeaways here for us? First study, this was the first study to validate text representations for computational literature review. And we see here that relatively simple models that are custom trained seem to work best. Yes, the raw word count does seem to do its job as well, but it doesn't actually show you the overall semantics of each of these articles that well. So actually a model like word2vec, which is relatively simple, but still using a statistical modeling concept, and actually something where we get to custom train based on our own text, which is different to glove, it seems to get the most kind of contextual knowledge of these different perspectives in these different articles. The next, this also brings up the next steps for this, which basically is for us to expand the list of the foundational texts, and then basically to test the various dictionary lengths. So we only tried 30 here, but to basically try different kind of dictionary sizes to see if we get more significant results and whether we're actually able to kind of use more words that are identified with each of these perspectives. To the model that we built. First, the added noise from the lengthiness of these articles, as well as the prominence of stop words in these articles, make it really difficult to calculate engagement metrics. We see cosine scores as well as the ratio metrics that we use for engagement hovering below 0.1 in value, often at like 0.05, which kind of makes it really difficult for us to determine whether actually the model is being effective. And this happens even after we take proactive text cleaning steps to get rid of stop words.
And this is where things get really difficult because we obviously care about how words are composed together, what words are used together and next to each other, which is why a model like Word2Vec does so well. But we actually also realize that in between these words are a bunch of stop words, so those are actually adding too much noise to the model, possibly making it less accurate than it could be. Second part is when we use the regressor to verify the model, we realized some of these columns are very sensitive. We use the date column to also determine the citation count, obviously, because we hypothesized that the longer an article existed, the more likely that it was referenced and cited by other articles. But basically, when we changed the date column to actually um, represent the number of years they existed instead of the actual year itself, it led to negative coefficient values, which probably goes to show that the column itself is actually really sensitive and the data itself is really sensitive and possibly overfitting to the model. And then all these things actually suggest that we need to take more proactive text pre-processing techniques as well as use a simple, less niche model because we want to avoid the idea of overfitting. This is specifically why we kind of came to the conclusion that a customized, simple model like Word2Vec really does well for us in our context, and also just in context of doing a computer-based analysis for a large amount of texts. Thank you, and feel free to reach out to that email to me if you have any questions or comments.